Hi, it's Richard again, and I'm here to teach you more about inscribed angles. So, a few videos ago, we learned that inscribed angles are basically any angle in a circle where the vertex is located somewhere on the circumference. And from the inscribed angle theorem, we also learned that the angle of the arc, or the angle of the subtending arc, is equal to half of the arc's measure. But you might think that inscribed angles are boring because we're only working with lines inside a circle. But in today's video, I'm going to prove you guys wrong. So first, using this extra circle over here, let's draw two secants that connect at a point outside the circle to form an angle. And let's label these points C, D, E, F, and G. Let's label this angle theta, this arc measure alpha, and this final arc measure beta. Now, what if I told you that theta was actually equal to beta minus alpha divided by 2? Seems crazy, right? But don't worry, we're going to use the inscribed angle theorem to prove this fact. First, let's draw a line from D to E, from D to G. And we notice that we now have a triangle CDG. And if we can figure out this angle here and this angle here, then we can come up with an expression for theta, our final angle in the triangle. So first, let's look at angle DGC, or this angle I'm tracing right here in blue. Let's look at angle DGF more specifically, and we notice that this is actually an inscribed angle. And therefore, from our inscribed angle theorem, angle DGF is equal to one half the measure of the arc, or 1/2 of alpha. Next, let's look at this angle here, DEDG, and I'm tracing it out in green. Now, it might seem weird that we're trying to figure out this angle because it's not even part of our triangle. But we notice that since CDE is a straight line, if we figure out angle EDG, then it will give us the angle of CDG. Now let's look at angle EDG. Again, it's another inscribed angle, and using our inscribed angle theorem, we can say that EDG is 1/2, sorry, that's a D. We can say that angle EDG is equal to 1/2 of the measure of the arc it subtends, or beta over 2. And likewise, or furthermore, we see that angle CDG is equal to 180 degrees minus angle EDG. So therefore, it's equal to 180 degrees minus beta over 2. So great. Now we know angle DGF and angle CDG. So now we can figure out angle DCG, or theta. We know that theta plus angle DGF plus angle CDG equals 180 degrees, right? So now let's just isolate theta on one side so that theta is equal to 180 degrees minus angle DGF minus angle CDG. And we can plug in the values we got to see that angle DGF is equal to alpha over 2. There's no angle sign there, my bad. But it's equal to alpha over 2. And angle CDG is equal to 180 degrees minus beta over 2. These 180s cancel out, and the two negatives in front of the beta over 2 become a positive. So it's equal to beta over 2 minus alpha over 2, which is equal to our initial expression up here. So great, we just solved a problem with secants using inscribed angle theorems. Pretty cool.